Okay, the fourth demo is looking at geometry generation, and this is in partnership with Rondel, and this is some work we did with them, developing some geometry generation for carbon fibre patches, and we've saved them many hours of manual work in Rhino by using ZebraCut. So I have here a file from Rondel. This will come from their CAD department, and these shapes here are carbon fibre patches. They're going to be different plies that need to be put together to generate the part. Now, there's a lot of parts, a lot of patches to be made, a lot of layers to be made from the carbon fibre, and it's important that when these layers are put together, the orientation of the carbon fibre, because there's a grain in the carbon fibre, needs to be differentiated every time. So first layer would go at 0 degrees, next one would go at minus 45, and then 45, and then minus 90, and you're always going to vary that. So for each one of these shapes, we need to generate each of these different 4 rotations, and they need to be ready to cut. A further complication is that once you've rotated them, these parts are then going to be larger than the roll of carbon fibre. So we need to do some part splitting. We need to break these parts up so that they can be cut from the roll of carbon fibre. So you can see here you've got the name of the part, the orientations, whether it's multiple materials. So for example, sometimes the innermost part is transparent glass, for example, or transparent perspex. So sometimes it's a different material. So we worked with them, and we used the existing functionality of ZebraCut and added 1 or 2 new steps. All these steps do is read off these particular fields and then configure the rest of the pipeline. So I'll run you through this manually just so you can see what's going on. First of all, we'll read the data, then we'll explode the blocks, we'll delete the geometry we don't need. We'll remove any duplicate lines that may have come through from the CAD team, make sure the geometry is joined. We will then go ahead and unnest all of these parts. So they've just jumped down there, and we'll look, they're in size order from largest to smallest. Once we've done that, we're going to go ahead and number them. So there we go, 1 to 8. We're then going to rename the labels a little bit. So they've got the actual part number, and then their B for block 1, block 2, block 3, along with the part number, because you can imagine we're going to end up with hundreds of these different parts. Sometimes we delete the smallest one, but we don't want to in this case. Then we're going to make the multiple rotations. So there we go, we've got our different rotations that we need already prepared. And the next thing for to do is the part chopping. You see these parts and these orientations are now too large to fit on our carbon fibre roll. So we'll do part chopping, and we're going to chop to 1200 millimeters. And there's a lot of configuration about how we chop and how we label things as well, because we want to make sure we can put these back together again. So we'll run the part chopping. These parts need no chopping because they'll fit nicely. But this one, for example, we've chopped it into part A and part B. And you'll also see we've got P for ply. So these are the different rotations, ply 1, ply 2, ply 3. I should have shown you that a moment ago. But there, for example, is part 8, ply 3, and there's part 4, and so forth. You can see we've chopped up the parts accurately, and they could then be put back together again when you come to fabricate. Now we need to sort out our labels and make sure we can actually pen mark them. Obviously it'd be nicer to inkjet them, but we're going to pen mark these ones. We're going to ungroup, we're going to do label to text, and then we could do text to curves if we want. You notice it's also done text fitting on here to make sure that this rather long label will fit within our parts. So it's carefully place that text. What else do we need to do? We need to make these back together as layer by internals. We'll group internals. We'll do some layer renaming. We'll change the selected layer, and we will then clear the layers to get rid of anything else that's there. And that is then ready to nest. So we'll go ahead and nest this. This time we'll use our advanced kit cutting functionality, which is called Magpie Tree, which is clearly where magpies hang out. We're going to import all the geometry. You can import folders, you can import files, you can import spreadsheets, whatever you want to do, we'll support it. But we're just going to import the geometry, and you'll see it's picked up all of our parts with their names. So if you know that you need 2 of these, because perhaps last time you fired a part or production lost it or something, we can just increase that and have 2 of those, for example. But that's all our parts. Then we need some sheets. So in this case, we're going to do a roll. Let's do a roll. We're going to have, let's say we're going to have 4 rolls, and we're going to make our rolls are going to be 1250 millimeters high, for example. Once we've done that, we can then go ahead and choose nesting and nest with carbon fibre. So we're going to fix the orientations. I'm just going to run quite quickly, 25 seconds, just for demo purposes. And then we'll just go ahead and run that. And it will go ahead and start nesting. Also, these nests will improve over time. You can see the parts do fit nicely and why they had to be chopped. There's no way you'd fit that in otherwise. All your parts are labelled, so you'll know which ones are which and how to put them back together again. If you want to keep track of how many parts they're broken into, you can have A of 1 of 3, or 2 of 3, 3 of 3, or even A of C, B of C, C of C, if you want to keep track of it in that way. It just depends how much inkjetting you're willing to do. Once that's done, we can then go and assign a tool. So let's laser cut everything, for example, just for purposes. Or we could go through and do inkjet marking on the labels. We don't want to cut the sheet, and then we'll just go ahead and preview selected geometry because we only want to do this part of the geometry. And we say go. And there we go. This is producing on the order of 100,000 G codes. And quite a few frames worth of geometry. So there we go. That is how we helped Rundle to save themselves hours and hours of manual preparation of parts. Again, if that was too technical for you and you're rather interested in sports cars, we can automate all of this. So again, let me just run that very briefly for you. So if I open up the file again, just from scratch. There we go, and I go back and I choose the pipeline that I've got. Again, that would normally be just default. There it is. If you are the operator and you just want to do production, you would literally just go run, and this is what Rundle will do. And everything is then prepared. We can then just move that out of the way. We can then go to nesting, import all the geometry. We can then add our roll. Make sure it's the right size, 1250. Make sure we've got, say, 3 rolls, and then we can again nest for carbon fibre and make a nest. So again, we want to give you the best of both worlds to show you we have the capability to handle complexity in your files, but we also have the ability to automate that complexity away so that you don't see it and the people running your machines don't need to worry about all of this. There we go. Thank you very much.